Eastern Pacific sea surface temperatures are rising. A sure sign an El Nino event is beginning. Dr. Phil Klotzbach breaks down the impacts on this year's hurricane season and updates his seasonal forecast. This is NTWC Live.
Good morning, everybody, and welcome to NTWC Live, and welcome to the 2023 hurricane season. So glad to have you all here today. An exciting program today. Dr. Phil Klotzbach is going to join us and talk about the updated seasonal forecast. And there's some changes, so you'll be anxious to hear that. Dr. Hal Needham is here. We'll hear more about the GeoTrek podcast. And, of course, Bill Reed is here as well to kind of guide us through the day. We want to thank our sponsors who make today a possibility, as always, USAA. Well, we appreciate them. They've been part of this program, part of the National Tropical Weather Conference from the very beginning, and we appreciate USAA for all they do. The South Padre Island Convention and Visitors Bureau. South Padre Island is the host of the National Tropical Weather Conference every year in the month of April. Mark it on your calendars now so that you can join us next year in April on beautiful South Padre Island at the Marriott Courtyard Beachfront Hotel there. Weather Boy and the Weather Company, also sponsors of NTWC. We appreciate all of you being with us once again today. All right, let's get over to Bill Reed to get started with our program today. Good morning, Bill.
Good morning. How's everything going?
Good.
A little interruption there, but the volume on my phone. So I got that fixed now. Yes, we got a busy day ahead of us, and it is June 1st, start of the hurricane season, and it's so appropriate that we have the gold standard for seasonal forecasting and many things climatological when it comes to the tropical Atlantic, and having Dr. Phil Klotzbach with us. So without further ado, Dr. Phil, did you get up and see your shadow this morning?
Well, thanks so much, Bill, and thanks so much to all of you for having me here again. It's great to see you virtually, and it was great to see all of you in person just a few weeks ago on South Padre. So yeah, let's get started and talk about the seasonal outlook. And it's always great, on the seasonal forecast day, we actually have something very interesting in the Gulf of Mexico that will be, I know Bill's going to talk about a little more after my presentation, but looks like the hurricane season's getting off to potentially a quick start here. So without further ado, the numbers for the 2023 season, we're forecasting now a near normal hurricane season, a total of 15 storms. Of those 15, 7 becoming hurricanes, and of those 7, 3 becoming major hurricanes. To note that 15 storms includes the subtropical storm that the National Hurricane Center identified a few weeks ago, that acts in line with the 1991 to 2020 average, which is 14 storms, 7 hurricanes, 3 major hurricanes. We also forecast accumulated cyclone energy, which is a geeky metric accounting for storm frequency, intensity, and duration of storms. So weak, short-lived storms generate very little ACE. Long-lived major hurricanes, such as an Irma or a Dorian, generate tremendous amounts of ACE. It approximates basically the kinetic energy generated by the tropical cyclone. You also see we forecast ACE west of 60 degrees west now. And why do we forecast that? Because if we have a lot of land west of 60 west, and so if storms are in that region, that tends to be where big problems are occurring. And I'll talk about how we can forecast that a little bit separately from basin-wide ACE as we move along. But when it comes to seasonal forecasting, as Bill said, we aren't looking like my meteorological namesake, the groundhog, Punxsutawney Phil, waking up and looking to see if we can see our shadow. We do use a lot of historical weather and climate data to come up with these seasonal hurricane forecasts. So we have weather and climate data goes all the way back to like the mid-19th century, but is reasonably reliable, say over the last 50 to 60 years, of both hurricane activity as well as wind patterns, water temperature patterns. And it goes back to a lot of pioneering research done by Dr. Bill Gray back in the early 1980s. Bill Gray was a professor at CSU for over 40 years. He pioneered the seasonal forecast, but also made fundamental contributions to tropical cyclone genesis, structure, intensity changes, a giant in the field of tropical meteorology. But he was teaching tropical meteorology in the early 1980s, and he noted, hey, when we have fewer hurricanes in the Atlantic, we also tend to have El Nino conditions in the tropical Pacific. And so there weren't a lot of people at that point that knew which years were the historical El Nino years and which years were busy hurricane seasons. And he knew this from basically studying a lot of data. And so he was able to kind of put together this kind of an empirical relationship where El Nino tend to cause fewer hurricanes. And the question is, why would El Nino, which is going on in the tropical Pacific Ocean, impact hurricanes in the Atlantic Ocean thousands of miles away? And so, we're going to talk a lot about El Nino and La Nina, so I figured it's a good idea to kind of talk a little bit about what these things actually mean. And so El Nino is warmer than normal waters in the eastern and central tropical Pacific Ocean, whereas La Nina is warmer than normal waters in El Nino, colder than normal waters in the eastern and central tropical Pacific in a La Nina event. And so why we care about El Nino and La Nina in the Atlantic is because when you have El Nino, you tend to get changes in upper level winds, especially at say 20 to 30,000 feet. So when you have an El Nino, you tend to get much stronger winds blowing out of the west, say at 20, 30,000 feet, whereas your low level winds blow out of the east. So when we think about this in a vertical cross section, we have more vertical wind shear, which is that change in wind speed and direction with height in the atmosphere in an El Nino, whereas in a La Nina, you tend to have less vertical wind shear. We tend to have less vertical wind shear the last few years, and that's been associated predominantly with La Nina conditions. That La Nina is over. We're likely transitioning over to El Nino in the next few weeks, next couple of months. So you would think with that El Nino, we could potentially be going for a much quieter overall hurricane season, but there's other stuff going on as well. But El Nino and La Nina is not the only thing that we use. We use a lot of other factors as well and try to convince you that hurricane seasons aren't random. If hurricane seasons were random, we would expect that looking at the 10 busiest seasons since 1950, difference from the 10 quietest seasons since 1950 for sea surface temperatures, you would probably see basically just a bunch of splotches, no kind of coherent spatial patterns. But we do see coherent spatial patterns where in the tropical Pacific Ocean, in a busy seasons, you tend to have La Nina, but also you have a warmer Atlantic providing more fuel for storms, but also associated with more unstable atmosphere, lower pressures, which are also conducive for thunderstorms that are the building blocks of the hurricanes. So now I want to go into more detail about the hurricane season, but just to give you an idea, these seasons, our forecasts, do show skill going back in time. A couple of things I want to draw your attention to is, the skill improves from April to June to August. Makes sense since we're closer to the events that we're trying to predict, but also, you'll see the red columns are higher, or the red bars are higher than the blue bars, which is good because that means the skill's improved in more recent years. I think one reason, because we actually have a better idea of historical data now. The models now can tell us better what weather and climate was like in the past, because basically today's models are higher resolution. So when we drop in the observations that we had in the past, the models can fill in the gaps better than they used to. And also we have a lot of climate models now that can actually skillfully forecast what is likely to occur for the hurricane season, which gives us increases in skill as well. So we've shown improved skill over the last 9 years and hopefully continue to improve skill in the future. But now to really dive back in, here again are the numbers: 15 storms, 7 hurricanes, 3 major hurricanes. And so how the heck do we come up with these numbers? Well, I always like to start by looking at the sea surface temperature anomaly pattern, or differences from average. So the first thing that kind of jumps out, it's warm almost everywhere right now. But to really focus on 2 regions, the tropical Pacific Ocean, the eastern and central part of that's where El Nino develops. You'll see that, if I were to show this map from a year earlier, there have been a lot of blue in that blue rectangle area. But now that blue has been replaced by orange, so we don't have quite El Nino conditions yet, but we're getting close to that El Nino threshold. Whereas if we look at the Atlantic, it's extremely warm right now, the eastern and central part of the basin especially, and that red rectangle highlights what's known as the main development region. That's called the main development region because that's the region where most of your major hurricanes form and intensify. That also is much warmer than normal. So we kind of have 2 pretty strong factors pushing at this point. So just to start by focusing on El Nino, here is the blue rectangle denoting what's known as the ever excitingly named Nino 3.4 region. That's what happens when you have scientists naming stuff. This region is the region that NOAA uses to monitor the strength of El Nino or La Nina. And so when water temperatures in that blue rectangle on average exceed 0.5 degrees Celsius or more warmer than normal, NOAA will declare an El Nino event, provided those water temperatures persist for several weeks. Alternatively, when water temperatures in that blue rectangle are 0.5 degrees Celsius or more colder than normal, La Nina will be declared by NOAA. So we've kind of flirted with that 0.5 degree Celsius threshold, but we haven't exceeded it for a long period of time as of yet. And also just to point out, 0.5 degree Celsius, about 1 degree Fahrenheit, seems pretty innocuous, right? But small temperature changes in the tropics make big differences in how the atmosphere then responds. Just eyeballing this map too, just as a point of interest, if you look at about 20 north, 130 east, you can see a very, very significant cold wake from formerly Super Typhoon Mawar in the western North Pacific. When you have very strong typhoons, obviously they have a ton of wind associated with them. They cause a lot of mixing and churning up of the ocean surface. And so you can see cold wakes from tropical cyclones on these plots as well. And so now what we're going to talk about is the forecast low-level wind pattern across the tropical Pacific as well as the observed pattern. And we're going to start by looking at that area denoted by the black rectangle. And you see there's a lot of oranges and reds in that area, and that was generated by the development of Typhoon Mawar, which formed at quite low latitudes. And the circulation around a typhoon on the southern periphery, you're going to have winds blowing out of the west because of that counterclockwise circulation. Those low-level winds blowing out of the west generated a tremendous amount of westerly winds. And the reason we care about that is because the western tropical Pacific is warmer than the eastern tropical Pacific. And so when you get a lot of westerly winds, that tends to transport that warm ocean water eastward in what's known as a downwelling or warming oceanic Kelvin wave. And you can have fun talking about that with your guests at your next dinner party. And so you can see that actually looking at buoy data. This is data across the tropical Pacific. If you look since the early part of May and you look at, say, 160 east towards 180 east, you can see kind of a slant. It's slanting from west to east, and you can see kind of that warming that's likely associated with that downwelling Kelvin wave propagating across the basin. So right now, we monitor sea surface temperatures, so we're on temperatures at the surface of the ocean, but it's also important to see the temperatures lower down in the ocean because those water temperatures are, if it's warm throughout the ocean, that will tend to evidence itself in surface warming later on. So I think El Nino is very likely to be announced in the next couple of months. And so, the big question is El Nino coming? Hopefully some of you remember legendary Chris Farley with his El Nino wrestler sketch back from, I believe, 1997. And I'd say the answer is certainly, I would say really strongly, yes, El Nino is coming. The big question at this point is how strong is El Nino going to be? Here's the forecast from the ECMWF, or European Center for Medium Range Weather Forecasts, prediction from the 1st of May. There'll be an updated prediction coming out in a few days. And this is basically an ensemble. And the way an ensemble is generated is you take your initial conditions, so your initial observations, and we know with those initial observations, they're not perfect, right? I mean, thermometer says 82, it can be 82.0, it could be 81.8, 82.2, and those very small temperature changes or uncertainties grow with time. So these ensembles kind of give you an idea of the uncertainty associated with the forecast. But you can see that all 51 of the ensemble members for September are calling for El Nino. Now, the ECMWF model has tended to have a high bias or a warm bias, but even if you kind of shift this distribution down a bit, likely still to reach that El Nino threshold. Anything above about 1 degree Celsius is considered a moderate El Nino, and above 1.5 degrees Celsius is considered a strong El Nino. I think at this point, I would personally favor a moderate strength El Nino event, just given the way that the subsurface looks. But certainly a strong El Nino event is certainly still a potential as well. If you don't like the European Center model and you love alphabet soup, here's a whole pile of different models with a whole lot of different acronyms. Forecasts for August through October, which are the peak 3 months of the season. Most of them are calling for El Nino. I would say El Nino is certainly a good bet. I'm not quite sure what that one statistical model calling for La Nina is. If we end up with La Nina in August through October, there's going to be probably at least one or two, if not more, PhDs right now on what the heck happened. I think El Nino is extremely likely this summer and fall. NOAA would agree. They have a 94% chance of El Nino with their latest probabilistic outlook. Basically 0% chance of La Nina and only about a 6% chance of neutral conditions. So El Nino looks like a really good bet for the 2023 season. And if we get El Nino, how does that normally behave? So here's an analysis of years since 1900 basin-wide activity. And so here, stars indicate statistical significance for those of you that care about stats. And you can see in general, you get more in La Nina, fewer in El Nino, and kind of middle of the road in neutral conditions. One thing I would like to draw your attention to is that if you look at the ratios between neutral or between El Nino and La Nina, you see stronger ratios for the stronger storms. And that makes sense because you can get weak, short-lived storms forming in fairly marginal environments. Whereas to get strong, long-lived storms like major hurricanes, if you get a major hurricane that's probably been out there for a couple of days, it needs a pretty large environment of conducive conditions. That's where you're going to see the biggest difference between La Nina and El Nino, because La Nina tends to make the conditions more conducive over a larger area than in El Nino. This gives you an example of the tracks of La Nina versus El Nino. And so here we selected, since 1900, the 30 years that were the strongest or 30 years that were the coldest are La Nina, 30 years that are the warmest are El Nino in the eastern and central tropical Pacific. The rest are classified as neutral. And you get about a 2.5 to 1 difference in terms of major hurricanes between La Nina and El Nino. You also see a modulation with continental U.S. landfalls, about a 2 to 1 relationship with hurricanes, and about a 3 to 1 relationship with major hurricanes, again, highlighting how the ratios tend to be stronger when you look at stronger storms. So overall, with all this talk about El Nino, I would say that's good, right? I mean, it tends to lower the odds of all of this stuff. And especially lowers the odds of these really nasty hurricanes. These are these $10 billion storms. These $10 billion storms are calculated based on the damage that they caused at the time and then adjusted by inflation, population, and wealth. So these are basically normalized damage storms. So let's say a storm that caused $5 billion in 1950 would likely cause well over $10 billion today. And you can see the ratios are a lot stronger for Florida and the East Coast than they are for the Gulf Coast. And the reason why that is likely the case is because storms hitting Florida and the East Coast often form off the coast of Africa, maybe form in the Caribbean, and those tend to be a lot more modulated by La Nina and El Nino than storms necessarily forming in the Gulf, where you can get storms forming in the Gulf. They can come all the way from Africa or from the Caribbean, but they also often form in situ in the Gulf, where the relationship with El Nino is not necessarily as strong. But overall, certainly you do see pretty significant modulations. In general, La Nina certainly loads the dice for impactful hurricanes for the U.S. as well. But I'm not necessarily sure that it's going to behave exactly like your normal El Nino behaves, and that's because the Atlantic is really, really warm right now. Apparently, I was quoted in some outlets recently saying the Atlantic is really, really stinking hot, and I'd stand by that. It is really stinking hot compared with normal. If we look at the eastern and central tropical Atlantic, so denoted by this black rectangle, the air waters there are extremely warm, much warmer than normal. The warmest on record, and there's only been 2 years since 1979 where the water temperatures in that region have even been within half a degree Celsius of their current values, those years being 2010 and 2005. And so it's important to kind of realize just how warm this is. So I think that is a big player. And one of the questions you might be wondering is, why do we care so much about the subtropical Atlantic? What does it matter about the Azores? We're not getting a lot of hurricanes out there, but it does matter. And that's because what happens in May can alter the winds that blow across the tropical Atlantic for the peak of the season. So if we look historically at the area that correlates the best with seasonal accumulated cyclone energy, that integrated storm metric, and we look at where the correlations are the strongest or where the correlations are the darkest. In general, it's in the Eastern Atlantic. And the reason why that's likely the case is because if the subtropics especially are warm this time of year, what that tends to do is weaken the Azores high. Warm water tends to lower the pressure. And if you have a weaker Azores high, you tend to have a weaker subtropical to tropical pressure gradient, and that results in weaker winds blowing across the tropical Atlantic. Weaker winds mean less evaporation, which means more warming, or basically warming faster than normal. But just if we look at the sea surface temperature pattern that's kind of quote-unquote optimal for a busy hurricane season, and just toggle back to what it looks like, it's not a correlation of 1, but it's pretty stinking close if we look at those two plots. And so we have a variety of different techniques that we use to come up with our forecast. We use a statistical model, which basically a statistical model is looking at conditions up through, basically up through today. So here it's a June model, so we're looking at conditions during the month of May. So we're looking at water temperatures over the Eastern Atlantic, which again is what we just talked about. We also look at low-level winds blowing across the tropical Pacific. When those are blowing strongly out of the west, like we observed a few weeks ago, when those winds are blowing strongly out of the west, what that tends to do is, again, transport that warm water from the Western Pacific eastward, whereas if they're strong out of the east, that tends to promote upwelling and cooling, and so that tends to promote La Nina conditions. And so we have two predictors here. The reason that one predictor is seen twice is because it spans both hemispheres. And so this model over time has shown reasonably good levels of skill, correlates decently well going back to 1979. There are some years where the forecast busts, and that's because obviously what happens in may change quite a bit. And even if you have perfect knowledge of the hurricane season, you can only explain so much variability in hurricanes, because remember, at the end of the day, hurricanes are weather events. Climate conditions will kind of load the dice, so to speak, to above or below normal activity. But again, hurricanes are weather events that can sometimes find, even in an otherwise, say, harsh environment, they may find an area of conducive conditions, or vice versa, where conditions are extremely harsh everywhere, but in a small little box, and that's where the hurricane happens to develop. Our forecast is well below the statistical model, and that's because we really do need to respect the possibility that we could get a very strong El Nino event this summer and fall. I think very strong is unlikely, but there still certainly is that potential. We also use statistical dynamical models, and the way that these are done is we look and see what the models are forecasting for the peak of the hurricane season. And this is stuff that Bill Gray couldn't have done in the early 1980s because climate models didn't really even exist yet. But now we do have climate models that can forecast reasonably well. And so we're not saying, let's take a model and forecast August 14th's weather in Denver. What we're saying is, let's look at a forecast for a 2-month average of water temperatures. And models can do a reasonably good job at that. And the nice thing is, when you look at, say, today's generation of climate models, they're also tested on historical data to make sure that, the models that are introduced today are improving on the models that were, say, there 5 or 10 years ago. So we can kind of get a good idea of the track record of these forecast models. So, for example, the European Center, or ECMWF, forecast model has hindcast going back to 1981. So we can see, okay, how well would the current iteration of the ECMWF climate model have worked at forecasting 1981? So we can get kind of a good idea of its track record. And so, for example, the ECMWF model for August through October is calling for the third strongest El Nino back to 1981, behind 1997 and 2015, but also the warmest sea surface temperatures in that area in the tropical and subtropical Atlantic on record. So that's an interesting combination. So I think that is what we're going to be really watching very closely is, does this forecast pan out? If the El Nino, say, comes on a lot stronger, then we likely would lower the numbers. But if, say, the El Nino isn't coming on as strong and the tropical Atlantic stays very, very warm relative to normal, then perhaps we would even increase the forecast. One thing I will want to comment on is the tropical Atlantic tends to kind of lock into whatever mode it's going to be in, starting at about mid to late June. So it's getting to the time now where we should start to see the tropical circulation really more responding like an El Nino, if it's going to. So that's one of the things we're going to be monitoring very closely here over the next few weeks. The European Center model, this kind of statistical dynamical hybrid model, also shows reasonably good levels of skill. We're also going a little bit lower than what it is forecasting as well because of the potential that the El Nino will be even a bit stronger than is being predicted. We use a bunch of other different models as well. We use the UK Met Office model, the Japan Meteorological Agency model, as well as the CMCC, which is based out of Italy. We also use analogs, and analogs involves going back into the past and looking for years in the past that had conditions most similar to what we currently see, but also we expect to see for the peak of the season. And there's not a lot of great analogs for this year because 1997 and 2015, if we look at May or even August through October, the water temperatures in the Atlantic were not nearly as warm in May as they are now, and probably not as warm in the peak of the season, because I don't expect those waters in the Atlantic necessarily start to anomalously cool at a really high rate. So it's kind of tough to actually pick really good analogs. But the 5 years that we selected were 1951, 1957, 1969, 2004, and 2006. Now, one thing I want to draw your attention to is that when we pick analog years, we are only selecting kind of that these years have broadly large-scale similar sea surface temperature patterns. This is not saying, say, for example, 1957 is an analog that we're expecting another Hurricane Audrey in late June. But if we look at the 5 analog years that we have, you can see there's a large spread in how much hurricane activity occurred. 57 in 2006 were a little bit below normal. 51 was near normal. 69 in 2004 were well above normal. I think, honestly, my favorite analog right now is actually 1951, because it ended up being a moderate strength El Nino event, which I think is a reasonably good bet at this point, but also had a pretty warm Atlantic. A year like 2004, the Atlantic was fairly warm, but the El Nino really was pretty weak until late. I think certainly we're going to see more of an El Nino fingerprint than we saw in 2004. But again, it's hard because the strong El Ninos of 97 and 2015, I just think the Atlantic is going to be a lot warmer this year than it was in either of those years. So there is a lot of uncertainty associated with these forecasts. These are the uncertainties. So this is probability of exceedance plots. So basically, historically, the odds of getting at least one hurricane is basically 100%. And certainly for this year, it's also 100%. Say for 7 hurricanes, the odds historically are a little over 30% that you're going to exceed that. This year, it's 50%. We use a different climatology to what NOAA uses for this chart, because to get kind of enough statistics to kind of make these plots smooth out, you need to use more years of hurricane data. Certainly, if you go prior to, say, 1970 or so, we may have missed a few hurricanes, just given either we had no satellites or really lousy satellites prior to the mid-1960s, and we weren't flying as many planes as we do now as well. To give you an idea, here's the uncertainty associated with the forecast. This is based on historical errors. These are similar to the ranges that NOAA produces with their forecasts. The reason why we do our forecast with whole numbers as opposed to doing the range that NOAA does is we obviously provide ranges very similar to this. This is in our forecast, but when it comes to kind of getting the general public to kind of focus, we like to kind of give our best number or our best guess, because if you give a range, a lot of times the media will jump on the high end of the range and say up to, say, 9 hurricanes, and then the general public hears up to 9 and thinks that means 9. Whereas if you say 7 hurricanes, there shouldn't be any confusion that that actually is 7 hurricanes, although I have heard people say that means 7 landfalling hurricanes, which is a very, very, very different forecast from 7 hurricanes somewhere in the Atlantic Basin. Just again, draw your attention, we also are forecasting ACE west of 60 degrees west this year, and that is what I kind of term like angst ACE, because if you got storms ACE west of 60, that's where problems typically occur, because there's a lot of land west of 60 in the Atlantic Basin. And so if we look at basin-wide ACE versus landfalling hurricanes in the North Atlantic, so not necessarily just the United States, but also including Central America, Caribbean, there's a decent correlation there. So, I mean, you are, just by forecasting basin-wide ACE, you are highlighting the potential impacts, but ACE west of 60 does show an improved relationship, again, because if you've got a lot of storms west of 60 degrees west, that is going to cause a lot of problems. And if we look at, say, a storm like Hurricane Dorian, generated a tremendous amount of ACE west of 60, and obviously that was an extremely problematic storm for the Northwest Bahamas. So typically, with the relationship with ENSO, you get more ACE west of 60 in La Nina years than you do in El Nino years. El Nino years tend to favor broadly favor recurvature, but also tend to be more likely to have fewer storms or less storm activity in the Caribbean. Your shear tends to be a lot stronger there, and that tends to, if you have high shear in the Caribbean, that tends to knock down storm activity there. And the Caribbean historically is an area where you can generate a lot of ACE because the waters there are really, really warm. We also provide probabilities of landfall, and these probabilities are based on historical data and then adjusted by our latest forecast. This year, the probabilities aren't particularly exciting because they're exactly the same as the long-term average. So just to kind of highlight, for landfalls, the probability this year for a major hurricane for the entire U.S. coast is 43%, which is the exact same as the long-term average. And you can see how it ranges for these various regions. We also provide similar probabilities for every state, for every county, for every parish in Louisiana along the coast, as well as Atlantic provinces of Canada, coastal states in Mexico, as well as the Caribbean and Central America. And the way that we did these probabilities is we selected all the storms that were within 50 miles of each county or parish using the Coastal Hurricane Tracks tool, which is fantastic. And what we did is we selected a 50-mile buffer around each county. And the reason we used the buffer as opposed to just using landfalls is because if there's a storm within 50 miles of your county, your life's probably not great. You're likely to be experiencing some fairly significant impacts. And so here we're looking at all the hurricanes within 50 miles of Plymouth County. I selected Plymouth County because that's the county I grew up in, so I figured we'd use that as an example. There have been 10 hurricanes between 1880 and 2020 to impact Plymouth, or to be within 50 miles of Plymouth County. So you can basically calculate how that converts to a probability per year. And then we adjust them again based on our latest forecasts, with the idea that in general, more active seasons have more landfalling hurricanes. It doesn't work every year. You can certainly talk about years that were fairly quiet, like in '92, which obviously had one major hurricane, but it was Hurricane Andrew. Or you can have a 2010 where you have 12 hurricanes in the Atlantic and no landfalls. But if you take 10 busy seasons basin-wide and look at 10 quiet seasons basin-wide, you're going to get a lot more landfalls in the busy seasons overall. Just to give you an idea of some of the probabilities that are available, here they are for various states. We do have it for every state from Texas to Maine, but just to highlight, for example, Florida, the probability in any year of a major hurricane within 50 miles. These forecasts aren't stagnant. We will update it again on the 6th of July and again on the 3rd of August. And the reason why we update the forecast is because we're closer to the events that we're trying to predict. By early July, we'll have a better idea of if the tropical circulation really is locking into El Nino. We'll also, too, by early July, we'll have climate model forecasts on a weekly timescale through late July, which will also be extremely helpful. And even the 3rd of August, while you're 2 months into the hurricane season, the Atlantic season is extremely peaked. About 95% of your major hurricane activity occurs after the 1st of August. So we have all these preparation meetings. We have a big hoopla about first day of hurricane season. And most years, not much happens in June and July. But once you get to August, season really ramps up. And Dr. Gray used to physically ring a physical bell every year on August 20th, signaling the active part of the season. I think it's like 85% of your major hurricanes occur between August 20th and October 10th. So it's a really peaked hurricane season. So keep that in mind. If June and July are quiet, doesn't necessarily mean the season is going to be quiet. But if you think KCSU's forecasts stink, we want to see what other people have to say, I invite you to check out seasonalhurricanepredictions.org. We're certainly not the only game in town. We've got about 28 different groups, I believe, now submitting forecasts. These include private sector weather companies, government agencies, as well as universities. And on the website, you can go to the website and get information on all the different groups, kind of a brief summary of the methodology that they use. And then most importantly, the forecasts themselves. And so here the forecasts are color-coded, where blues are government agencies, purples are private sector weather companies, greens are universities. The orange dot represents the value to date, so we haven't had a hurricane yet. And the orange is the average of the average, so basically the average of all the different groups. So right now the average forecast is for 7 hurricanes, which also happens to be what CSU is forecasting. Sorry, I screenshotted this before our updated forecast. So if you go to the website, seasonalhurricanepredictions.org, you should see the updated CSU seasonal hurricane forecast on that as well. One thing I want to draw your attention to is that, if you were to look at this chart last year, there wasn't a lot of spread, whereas this year there's a tremendous amount of spread. You have some groups going for a well below normal season, and some groups calling for an extremely busy season. For example, the Institute of Meteorology from Mexico is calling for only, I believe, 5 hurricanes, and you can see some other fairly low forecasts as well. But then you have the UK Met Office, as well as Skyfora calling for a hyperactive hurricane season. So there's a lot of spread. I think just highlighting the uncertainty in this forecast, and I think a lot of it is how the models are responding, or how the forecasts are responding to the extremely warm Atlantic, combined with the strong, potentially moderate to strong El Nino event. And so with that, I'd like to thank you for your attention. I always like to finish with an admonition from Arago, who was head of the Paris Observatory in the mid-19th century. And he stated that never, no matter what may be the progress of science, will honest scientific men, keep in mind this is the mid-19th century, so honest scientific men or women who have regard for their reputations venture to predict the weather. And so with that, I will put up my contact info and I'll try to answer any questions.
Okay. Great talk as always, Phil. Just a quick mention of our sponsors once again. We're very thankful for the support we get from USAA, the South Padre Island Visitors Bureau, Weatherboy, and the Weather Company. This is truly an interesting forecast this year. I mean, I think you got around to the point right there when you hit the analogs is there is none. So there's a great, I would think there's more uncertainty in your forecast than the statistical average, that you end up with a range on that. Is that a true observation?
Yeah, I mean, I would think so. And I think even when I was on in April, I said a similar thing. Like there's a lot of ways this could go. And so, one of the things that we think about is in an El Nino, a lot of the reason why we get that strong shear is because when you have an El Nino, you get that heat source, and that tends to be in the central tropical Pacific. And when you get that heat source, it raises upper level heights in the Pacific Ocean. That tends to increase your shear. Whereas, and in the Atlantic, historically with El Nino, the Atlantic may be a little warm, maybe a little cold, but not really that much of a signal there. So that really ramps up your westerly winds. Whereas if you look at a year like this year and say the current Atlantic water temperature anomaly, so say the half, 3/4 of a degree warmer than normal persists, and you get that at the peak of the season, you're going to get heights going up there as well. And so that gradient in heights is going to be a little bit less, so you're not necessarily going to see as big of a shear modulation as you would in a quote-unquote normal El Nino. And you're starting to see that in some of the dynamical models. For example, I looked at like the European Center model, and it's forecasting a pretty strong El Nino event, but its shear, which in say like 97 or 2015 was like 2 standard deviations above normal, so really strong. This year is only about half a standard deviation above normal. And I think that, and obviously these dynamical models should at least be physically consistent with, they're forced by the boundary conditions, so that should be physically consistent. So I think that's kind of where the big question lies is, do these things play out the way that the models are forecasting? Because I mean, certainly, if you get a monster El Nino, that's going to tend to dominate. But if El Nino comes on, but it's kind of weak, and the Atlantic stays as warm as it is. I mean, right now, the forecast winds coming up over the next few weeks over the Atlantic tend to be fairly weak. So I don't think those warm anomalies in the Atlantic are going anywhere. But at the same time, we have a pretty strong, I think, downwelling oceanic Kelvin wave in the tropical Pacific. So if anything, from when I put out the forecast in April, I'd say if anything, we're more confident that El Nino is coming, but we're also more confident the Atlantic being really warm. So it's kind of a matter of seeing how that plays out. And one thing that we have now that we didn't have, when Bill Gray started doing these forecasts, is climate models can forecast wind patterns 1, 2, 3 weeks out fairly well. So that is helpful too, because you can kind of see, one of the things that I'm looking at right now is, okay, are we starting to see more upper level easterly winds near the international date line, kind of highlighting like you're getting more convection, more thunderstorm activity there? Because if that locks in, that tends to be, okay, El Nino's dominating. Whereas if that doesn't develop, and especially one thing we have observed over the Caribbean is the trades have been very weak. And normally in an El Nino, those trades should be strong, because in El Nino years, you get high pressure in the Eastern Pacific, high pressure in the Western Pacific, low pressure in the Eastern Pacific. And so that tends to drive stronger trades across the Atlantic. And right now the trades are weak. So saying, is El Nino starting to, exert its influence on the large scale circulation. So that's kind of one of the big things we're going to be looking at the next few weeks before the July forecast.
Mm-hmm. Yeah. The other thing I was wondering with the eastern half of the Atlantic, all the way from the subtropics to the tropics, staying warm like that. It sounds like the confidence in the model forecast of that has gotten much better since I was doing that sort of thing. Wouldn't that suggest we might get storms, the systems come off Africa, develop quicker, and perhaps maybe have a more of a little higher latitude potential for very active and tracks outside of where the big shear influence of El Nino might be?
Yeah, I mean, I would think that tends to be a little bit more likely. So, historically, El Nino tends to knock down your storm activity in the tropics and tends to actually maybe even slightly favor activity farther forward, because when you have an El Nino, it tends to increase your shear in the tropics and actually reduce your shear a little bit farther forward. El Nino also tends to favor recurvature. Not saying you can't get straight moving storms in El Nino years, but that subtropical high tends to be a bit, or you tend to get kind of an erosion of that the western periphery of that Bermuda high. So we'll see exactly how that all plays out. But I would say certainly given, how warm. So one of the other things that we look at with the El Nino and La Nina is El Nino tends to exert a stronger influence later in the season, because kind of what says why the Atlantic season doesn't start and we're get busy, say, in July typically, is because it's too dry and it's too cool. Whereas this year, that's probably not going to be as much of an issue early. Whereas El Nino tends to really kill your late season storms, because what kind of kills your late season is the shear gets too strong. And so with El Nino, that tends to increase the shear such that, say your shear you normally get in October, you're now getting in September. And so that tends to really kill the second half of the season. So there's a little more speculation kind of seeing how all that plays out. But certainly, given how warm stuff is now, that would probably tend to favor maybe something, a little bit earlier on, especially if we can get either subseasonal variability that would tend to counteract El Nino. But again, really what I'm looking at right now is to see, are we starting to see kind of a consistent El Nino-like circulation pattern? And that hasn't locked in yet, but maybe we'll start to see it lock in more towards once you get into July.
Yeah, that's not unexpected. To me, it was, we might not even see the full effect of it till we get into August, for that matter. But Hal, how about if you jump in right now?
Phil, excellent presentation. I had a question for you. I thought it was really interesting that you were taking Plymouth County and looking at strike probabilities, or say hurricanes, tracking within 50 miles. Do you actually do county and parish statistics like that, or were you just showing like it could be done?
No, we have it for every county.
Oh, that's fascinating.
Yeah.
So how could people find that?
It's all on our website.
Okay.
So we have probabilities for each county. And yeah, basically what we did is, working with a colleague, we basically did it we did it manually for every county using that coastal NOAA hurricane tracks tool. You could automate it as well, but wanted it to do it that way, just such that anyone could go in and do the exact same thing that we did and get the exact same numbers.
So you did like a 50-mile buffer. You're looking at the long-term climatology, and then you're adjusting it for this season.
Correct. Yeah. So we have basically the number of named storms, so tropical storms and hurricanes and major hurricanes within 50 miles of each county or parish along the coast from Texas to Maine. And the reason why 50 miles is nice is because it smooths out some of the noise you get from, say, like, a storm making landfall in one county and just missing the other. Plus, it also tends to help smooth out some of the noise where you have some counties that have less coastal distance than the county adjacent to them. And certainly if there's a storm within 50 miles of your county, some places in your county is probably not having a very good day.
Yeah, thank you. That everybody obviously wants as localized info as they could find. So I think people will be really interested in that. Phil, a second question for you. When you showed the long-term climatological averages during a La Nina season, ENSO neutral and El Nino, like, for example, I think the long-term climatology for La Nina seasons for named storms was like 14.4. That's not that far off of the last 30-year climatology, which surprised me. I would have thought the last 30 years would be pretty close to ENSO neutral, but it's closer to La Nina. Could you explain that?
Yeah, so there's a couple of things going on. wanted to be able to do El Nino neutral, La Nina, and do a climatology, went back to 1900. And so we're naming a lot more storms now than we would have in, say, 1900. So if you go back historically and like broadly sample, you kind of have an even distribution sample throughout. But if you were to say go back and use like estimates of maybe missed storms, that number in that La Nina years would probably be higher. Should be higher instead of 14, maybe like 16 storms. But we didn't talk about today, but we actually, this year notwithstanding, we actually over the last 30 years have trended more towards La Nina conditions in the tropical Pacific. The last 30, and so with that, that's tended to favor Atlantic hurricane activity, but disfavor Pacific hurricane typhoon activity. And since the Pacific is a much larger ocean, a lot more warm ocean heat content, when you disfavor the Pacific, you actually knock down global storm activity. So globally, we've actually seen a decrease in hurricanes, a significant decrease in hurricane strength systems since 1990. Now this year with El Nino, likely probably to actually see, more storm activity in the Pacific Ocean. Obviously, we're off to a pretty big start there. It kind of remains to be seen exactly how this plays out, but obviously, yes, a lot of the reason why those things were the way they were was because you are looking at older data basin-wide, and so you are probably missing some storms, especially the weaker storms earlier in the record.
Thanks, Phil. That makes a lot of sense. Bill, I've been monitoring the questions online. Is that okay if I read a few of those?
Go. I have two, but I'll let you take it. Thank you.
Okay, you're welcome. We could mix it up. One from our dear friend Casper here. He said, "How would a weaker than average subtropical high in the Atlantic factor into the intensity and reach of the Saharan dust?"
Well, so yeah, I mean, so typically the dust, if you have strong dust outbreaks, tend to get stronger, lower and mid-level flow. So that would tend to be associated with a stronger subtropical high effectively. So, but when it comes to the dust, a lot of it it's not necessarily when you get vigorous easterly waves or these thunderstorm complexes coming off of Africa, they tend to be associated with dust when they come off of Africa. And so getting dust in the eastern and central tropical Atlantic doesn't necessarily mean, that's, the season's you're not going to have a lot of storms. It's more if that dust gets pushed all the way into the Caribbean. That tends to be a sign that you have a lot of strong low and mid-level flow and a lot of stable dry air. And so that, when we looked at this historically, dust in the tropical Atlantic, in say June, July, has a fairly low correlation with basin-wide activity, which actually mostly occurs later than that. But if it goes into the Caribbean, that's a sign generally of a strong low and mid-level jet, and that tends to mean too much shear and likely a less active hurricane season overall.
Thanks, Phil. There's a question here from Margaret or WDSU chief meteorologist. She said, "Sorry, did you say the tropical Atlantic is stinking hot or the subtropical Atlantic is stinking hot?" And then she said, "Sorry, I do love the quote."
Hi, Margaret. I would say both are warm. The subtropical, so the eastern Atlantic right now is where the warmest anomalies are. But given the wind forecast coming up over the next couple of weeks, the tropical Atlantic is likely to warm. It's always warms up from winter or spring to summer, but it's going to warm up probably a little bit faster than normal. So if you, in May and even in June, your correlations tend to be highest in the eastern Atlantic. By the time you get into July, that's when you see the correlations peaking or getting stronger in the main development region itself. So it's interesting. If you look at June, there's not a ton of correlation between water temperatures in the eastern Atlantic and in the main development region. It seems to be more in July where they tend to lock in together in more detail. And I think there's a lot of July gives you a lot of information. July is usually a good month from a prediction perspective because you haven't had a lot of storms yet. The season doesn't really ramp up till August, but July is typically when the tropical atmosphere really locks in whatever mode it's going to be in. So you get from a statistical perspective, if July tells me just about as much about the season as August and September does from a prediction perspective. If you're looking at the large scale, like the winds and the pressures. So the nice thing is now in June, we can actually look at forecasts from models for July, and it gives us kind of like a 1 month lead time that we used to not have.
Thanks, Phil. Bill, do you have any other questions?
Yeah, another one of Casper's that I had not seen a report on before is fascinating about a study that correlates the 2019, 2020 wildfire extremes in Australia as a contributor to the La Nina, triple La Nina we had there. Is that something maybe you could, in the future, maybe factor into the seasonal forecast for the Atlantic season?
I mean, we look at this stuff on seasonal timescales. So, I mean, yeah, if you have, there was a study that came out that kind of argued that kind of helped kind of maintain that La Nina for longer. I mean, what we look at is basically, if you have a strong enough wildfires, that should be in the models, such that they would basically be able to kind of assess basically how that would then change the circulation. But it is pretty fascinating to see how wildfires can really change. For example, a couple of weeks ago, we had a lot of smoke in Colorado from wildfires from Alberta. And because of that, a few days earlier, the models were really aggressive at thunderstorm activity, but because we had all that smoke, we didn't get any solar radiation or very little solar radiation. So we didn't get the daytime heating that we needed to destabilize the atmosphere, and we got zero rain. Whereas basically, Alberta's smoke probably cost us half an inch of rain, although Colorado, we got 6 inches of rain in my house in May. So still doing very, very well in the rain department here.
You got as much rain as I did. That's incredible.
Yeah, that's a lot for Colorado. I know 6 inches doesn't seem like much for Texas, but for Colorado, that's a lot of rain in a month.
Wonderful. Well, Phil, it's been great. I understand you have to leave us kind of early, and that was the last of the questions I had on there. So stick with us if you can, but I think we're going to shift gears right now. I'm going to give us a quick update on our little disturbance going on in the Northeast Gulf.
Thanks so much, everyone. Take care.
Thanks, Phil.
Okay. See if I do this right. Okay. Hit an update on that now. Overnight, this cluster of thunderstorms maintained and persisted, and even have some hint of some banding structure. And Dr. Bevan increased the interest in this to a 50% probability that something could develop before things get more hostile. It remains to be seen. It's still obviously in its developmental stage. Surface plot, the latest version, it's obvious we got a low there. Pressure's down below 1,010 in the area there, so it's probably getting fairly close to depression level, at least on the pressure side on that. This is the outlook that Jack put out, and it shows it's basically forecast to and I'll show a little bit of that, drift south and southeastward over the next couple of days and become more hostile in the environment. The guidance that they were working off of this morning does capture that down through there, and then a few of them, the longer range models, pick it up and accelerate it off to the east as the westerlies intensify down there. None of the models are excited about it intensity wise, maybe briefly getting the tropical storm strength. As far as the basic environment that it's situated in, where it is right now is in only marginally conducive temperatures, but with a southward drift, it runs over 28 C water in the Eastern Gulf, and even a little warmer as it gets further south. So that's fairly favorable. The other factors are dry air and wind shear, and this is the water vapor loop that we're looking at this morning. And the disturbance is actually sitting in a fairly quiet area wind-wise, and obviously it's a moist area, or we wouldn't be getting the convection we see there. There was an upper low in the westerlies that has been pretty much parked in that area for a while there, and as happens sometimes, it develops down to the surface, and over warm water can be of interest tropically. A lot of dry air to the south of it, and stronger westerlies in the direction it's heading. This is a nice feature on tropical tidbits of where they underlay the surface pressures with the mean layer relative humidity and winds at roughly the middle to lower upper levels of the atmosphere. And this morning it shows the light winds and moisture associated with our disturbance, the dry air coming in on northwest flow to the south of it, and pretty quiet blocky ridge in the north of it. time step through there and it starts moving south. It looks like that's about its peak of favorable conditions there. And shortly thereafter, the dry air and northwest flow take over, and it becomes a very hostile environment by this weekend. We shall see. It's very typical looking system for the early part of the season. Nothing obviously tropical on the development there, and it becomes a tricky forecast. There is a scheduled flight. The last I saw, it hasn't departed yet. It's only a short trip from the Keesler Air Force Base down into the system. I think 19Z was the forecast fixed time at the center point in there. So there you have it for today. Everything else is quiet in the Eastern Pacific, and nothing else is forecast. So Hal, you got some info for us on the GeoTrek side of that. I'll turn it over to Hal.
Yeah, thanks, Bill. Great forecast there. Really interesting here on the first day of hurricane season. Well, the GeoTrek project travels the world to share stories about extreme weather and natural disasters not covered by the mainstream media. With all this attention and interest on seasonal hurricane forecasting, we were interested to have a conversation with Dr. Phil Klotzbach about the backstory behind hurricane forecasting, how he got involved into it, and how this science developed as well at Colorado State University. I'm just going to share a little excerpt here from the conversation I had with Dr. Phil. This will just take 1 second here to share my screen. So for some reason that dropped off. So I'll just talk a little bit about it. We have a podcast coming out with Dr. Phil Klotzbach. It's going to launch this upcoming Tuesday, June 6th. It's called The Janitor Throughout the Data, the backstory of seasonal hurricane forecasting with Dr. Phil Klotzbach. He actually gets into the story that the seasonal forecasting, in a sense, was not intentional. So Dr. Bill Gray, his academic advisor, was involved a lot in aircraft reconnaissance data, especially in the Pacific. And the story goes, in the early 1980s, there was a stack of critical data that were really in paper form. This is before a lot of people were using high-end computers. And the stack of paper was on a desk right next to the trash can, and the janitor, the custodian, threw out the papers. And so this was a critical area of research that they needed, and the papers were gone. They were digging through trash cans. They couldn't find it anywhere. And so they actually ended up redirecting into seasonal hurricane forecasting. And so Phil tells a story on this podcast that's launching this upcoming Tuesday. You can find it on Spotify, Apple Podcast, or wherever you listen to podcasts. Again, that's a GeoTrek podcast with Phil Klotzbach coming up next week. Hey, GeoTrek will be on the ground in hurricane zones, forecasting and reporting on what we're seeing this hurricane season. And if you want to see a little bit about that, if you live in South Alabama or the Western Florida Panhandle, tonight there's a hurricane special on NBC 15 in Mobile and WJTC UTV 44 in Pensacola. That's at 6:30 Central Time tonight. It's a hurricane special about the work we're going to be doing with GeoTrek this year. Again, we'll be going into disaster zones. We'll be going in along the coast, helping to forecast and just show you what's happening with a big focus on the impacts. Bill, Alex, Tim, everyone else, really appreciated the broadcast today. Always good to hear from Dr. Phil. I think a lot of us, it was great to get the updated forecast and to hear the latest perspective from Phil and the folks there at CSU.
Great, interesting stuff, Hal. That's really sad. All that data was lost. That was kind of what I wanted to do research on at one time. So I don't feel so bad now they're not doing it. The data was gone. But
no, something that really struck me from this podcast with Phil is that we all hit roadblocks in our research or in our path in life. And sometimes people just get discouraged and want to give up. In the case of Bill Gray, this actually redirected him into seasonal hurricane forecasting, that he wasn't really planning to do that. And then that's what he became famous for. So it's a good reminder when we hit roadblocks in life, maybe redirecting actually can take us on a better path.
Yeah, Phil likes the Yogi Berra quotes. I like the one that when you reach the fork in the road, take it.
That's right. Yeah, no, he has great. Phil has great quotes, and obviously so did Yogi Berra.
Yeah. Well, that's all I have. Alex, do you have anything for the audience?
Well, I think that's pretty much it. We had a really great show today. Next week, we're going to be talking about how the weather conference that we put on really helps broadcast meteorologists out there. And we also want to say thank you to our sponsors, USAA, South Padre Island Convention and Tourist Bureau, the Weather Company, the Weather Boy, and other folks who help make this podcast and live cast possible. Thank you to everyone for joining us today. We hope you enjoyed this episode of NTWC Live Hurricane Center Podcast. If you did, head over to Apple Podcasts and leave us a 5-star review. And join us next week. This is NTWC Live.